Welcome to lesson 18 of Learn C. And in this lesson, we're going to actually do what our boss asked. We're going to be able to print out the calibration data, slope, intercept, r-squared, for 3 years worth of data that was given to us in this folder, calibration data. I've already made project lesson 18 in here, and what I've done is I've copied all of lesson 17's program into lesson 18, except I've erased the main. So we're going to start with an empty main, but we have the get slope, get intercept, and get r-squared subroutines. Cool? And then also what I've done is I've taken in lesson 18, I've made a directory called data, and I've copied all 1095 files from calibration data into this folder. So it's in my project folder. So there's a folder called data inside my project folder, lesson 18, and in that folder data are all these text files. A note about the text files. I did this on purpose. I made these text files, by the way. I made them with a different program. And if you notice, they're named all numbers, 2015-001, 2015-002, all the way up to 2015-365, and then 2016-001 through 2016-365, then to 2017-001 to 2017-365, right? I got to be honest, I don't know if there's a leap year in there. I might have messed up, but this is just a hypothetical here, right? And so I didn't do it day, date, year. I didn't do all that stuff because it makes it easier on this program that we're going to write. And that's good advice, actually. When you're writing out a bunch of different files on a certain topic, it's good to name them in a way that it's going to be easy for somebody else to load them all in. And so one of the upshots of this lesson is how do you name files so that they're easy to load in C and easy to manipulate. So this is really easy to do. Turns out, it's really easy to make those file names in C using strings. So that's what we're going to do first. First thing I'm going to do is I'm going to be able to make the file names, make a loop that's going to have all of these file names printed out basically to the screen. Then we're going to open each one up, analyze each one, and print out the result. So that's really what this program is going to do. But first things first, let's make this string here. Moreover, it's going to have the name of the file 2015001.txt. But before it is going to be data. It's going to be this data data directory. So we need to be able to tell it both the directory, the file, the folder that it's in, and also the file name itself. So that's what we got to do, and we're going to need string.h to do that. What's in string.h? So if you go to c++.com, string.h, in here are all the different string.h functions. We're going to use string copy and string cat. Those are the two things we're going to use. And we're also going to use SprintF, which is in standard.io.h, I believe. So in order to do that, I need a couple of character variables. I need char a file name. I'm making it 50 long, but it doesn't need to be nearly that long because I can waste memory in this program here. I'm going to need a string for the year and a string for the day. So we're going to we need an integer for the year and an integer for the day. So now I'm going to do quickly, I'm going to do a for loop. For year equals 2015, year less than or equal to 2017, year plus plus. For day equals 1, day less than or equal to 365, day plus plus. Cool, huh? So first thing I'm going to do is I'm just going to print out what I think I've got here. So I'm going to print f %d, d, and then right after it, %d/n. Just to see, this is just a start. This is just doing a very simple starting program. This is a good programming strategy, which I've talked about in class, hopefully, which is, you know, start really small. Start with a small data set, start with a small thing and test it out. Make sure that the algorithm works before you write the whole thing out. Now, I write the whole thing out for these lectures because I've been doing this literally since before you were born, maybe since your parents were children. So, I mean, it's been a long, long time since I've been starting programming. So I'm an old pro at all this stuff. So it's easy for me to write the whole thing and not make a mistake. But a lot of times when you're just learning and trying stuff out, it's good to start small and try it, just a small thing. So, and I'm going to teach you a lesson about printing out numbers here with the %d command. Oops. Oh. Boy, I messed that up. Look at me saying that I know how to do stuff without making mistakes, and then year, day. It looks pretty good, right? Except when you get down below 50, when you get down below 100, it's only 2 characters, and when you get down below 10, right, it's not 001, it's just 1. So how do we format that? How do we format that so that it looks like the file name? If you remember again, if you look at the file name, it's 2125001. So it's always 7 characters long here. So how do we constrain that? How do we force that to be true? Well, you just go 03 day. So that means we want it to be 3. We want this second term to be 3 characters long, and if it's less, and filling in the front characters if it's fewer than 3 characters with zeros. Let's see if that works. Yep, I'm looking at it and all the variables look right. 097, 096 looks good. 001, 002, so 03, that's a trick that we just learned, right? So formatting, you can format floating point numbers to have just 2 decimal places and all that stuff. So by adding things in front of the D or in front of the F, if you're doing integers or floating point numbers respectively, can alter the format of how it gets printed out to the screen. Okay, I just did that to sort of show that what 03 does. So now we want to build the file name. So the first part of the file name is the folder data. So that's with string copy. So string copy to the file name / data //. We're doing the first thing we're doing is the folder. I did double slash. Why? Because if you do single slash, it's going to, you just take single slash out and see what error it gives you. It needs to, backslash is a hashtag character because it actually has functionality associated with it within the C program. So, so like the double quotes and the single quotes in the hashtag characters, if you remember all the way back to the Hello World program, if you looked at all the different backslash characters, backslash itself is one of them, so you had to do a double backslash there. And then I want to add the year, so I'm going to do that with the SprintF command. %d year. Oh, no, SprintF to s year. And then concatenate that, string cat, file name s year. And same with day, SprintF s day, %00303d, oops, quote, %03d, day. So a moment about SprintF. SprintF is just printf, but not to the screen, or not. It's to a string. So print this. This is an integer. Print it as a decimal place, as a base 10 integer into a string. Convert this integer into characters. That's what SprintF does in a specific format. So strings are not the same things as integers. So quote 3 is not the same thing as the number 3, for example. So % as a string, file name. So we started with data, did the year, did the day in this new 03 format, and then .txt. Let's see what that looks like. Looks good, right? Wow, so we were able to do that. So now the program becomes much easier, right? So now load the data, open the file. And in order to do that, we need file, star p. We need all sorts of other stuff, right? We need float x 10, float y 10, float m b r2. And we need an I. I need an I too. Equals get slope xy. B equals get intercept xy. R2 equals get R2 xy. And I can even do tab here so that we can see the name and the slope and the intercept there if you want. So I did the first step one was here getting this file name ready, then actually reading the data and then printing out the answer here. Let's try and see if that works. Didn't work. Look, there's something's wrong with the data there. I do wrong. I'm going to pause the thing and figure out why. Okay, I found the error. I made a mistake here, which is in data, you don't need the first backslash, right? Either you can say dot, the directory I'm in, double backslash data, or just leave it out. And so I just left it out because I know I'm in the directory I'm in, and if you can see me, I fix it. So it's just the file name looks like that. So when I fix it and I run it, wow, that's great. So I've got the data file here. I've got this. It looks fantastic, right? It did it. And by the way, if you do all the math all the time that it took me to get there, it's less than an hour, right, to have gotten all these points. It's still not perfect yet because this is just to the screen. I need to write this to a file instead of write it to the screen. And moreover, I don't want this thing. I actually want something that I can use in Excel to print out. So that's going to take a little work here. So first thing I'm going to need is a file fp out, right? And then I'm just going to open it here. fp out equals fopen output file.txt write. And then at the end, way down here, fclose fp out. And then I want to say the number I want to go out in the first column, so that's going to be an integer. It's going to be the day plus the year minus 2015 times 365. Good? Let's try that. Execute. And I haven't done the I haven't printed it out. I'm still going to print it out to the screen just to look at it real quick first. Oh, so here's the number, and I just need to not print out the thing. So hang on, let's do that. So then I don't need this. And if you want to make it good, you're going to say \tab, \tab, \tab. That's nice formatting too, to make sure that it's going to look, that it's going to input into a into an Excel spreadsheet easier that way. Yeah. So let's just go, let's look at one of the boundaries and see if I did the boundary right here. So 365, 730, right? So 730 and 731. 730, 731 looks right. Okay, looks good. So now all we got to do is just say fprintf to fp out, da da da. Now we go into Excel. Desktop, C code, lesson 18, text files. So let's just look at slope first, right? Insert charts, XY scatter chart. Let's just do straight lines. Huh. Wow, that's a really big trend. It's noisy, but that's a trend that we could see. So that's amazing, right? It's just, and it's worse in the summer. It's cold, it's dark, it's bottom in the winter, it's top in the summer, and there's a spike here happens. That's kind of it. It's like a rectified sine wave. It is, because that's, I wrote it. I made the data. So that's what it was supposed to look like. Okay. If I want to look at both slope and intercept, boy, that's even weirder looking, huh? So, but there's a trend here. You can actually see a trend. You can see that if you are able to look at the data over a 3-year period, you can actually see a trend and figure out what's happening, what's happening on January 1st each time, and what's happening during the summer and the winter, and what's maybe something temperature related, something like that. That's pretty cool. All right, that beats the fool out of manually doing it, right? True. I was able to do 1,095 files with just this one program. I mean, I had to build it up because I'm demonstrating it to you guys, but I would have just dove right in, written this program real quick. I probably would have already had the linear regression subroutines in functions in my bag of kits somewhere. I would just copied it from an old program. And boom, I was able to do this in, probably a little over an hour, as opposed to almost 2 days of pointing and clicking. Again, this is the power of C. It's really good. And that's the end of lesson 18.